Proper drainage is important for agriculture growth and sustainability. Recently, we have experienced headline events impacting many farmers and ranchers across Saskatchewan. Going into the future, we can continue to expect to see these weather extremes, so it is critical we have an understanding about the role we play. With knowledge and resources, it is possible to reduce the impact that the climate plays on our operations.
The word climate comes from the Greek word klima, which means an inclination or a tendency. So it really means what the weather tends to be like, not what the weather is on a given day, but over a long period of time. What's the typical weather at a location on the Earth's surface? Well, if that's climate, then climate change is some kind of long-term shift in the average weather or the range of weather.
When looking at a map, you can clearly see the impacts of the climate by looking at the land cover. You can see the climate because there are forests, grasslands, and deserts. Each region has evolved in different climates. It's taken thousands of years of weather to produce these natural systems. If you start to look at land cover and match that up with the current climate and trends, you can start to see whether there are changes occurring within the climate. Climate change is some of the variation in the average or the variability, and if the climate changes, you will get different and unexpected weather.
We use the old expression that weather is what you get and climate is what you expect to get. So the weather can be anything on a given day, especially in Saskatchewan, but we expect certain weather based on the long-term climate. I was picking up a rental car in Calgary, and the young woman who gave me the car said she had just received a call from Texas. And these people said, we're renting a car in Calgary, it's April, what kind of weather can we expect? And of course it could be anything. And that range of weather is a characteristic of our climate. We can also describe the difference between weather and climate using an analogy or a metaphor like that the climate is your wardrobe and the weather is what you're wearing on a given day. So in Saskatchewan, people have a huge wardrobe. I mean, where else on earth would you have a parka and shorts and a t-shirt in the same closet? I gave a talk in Tabor, Alberta, to a room full of ag producers. And after my talk on climate change, a manager of an irrigation district came up to me and said, Dave, nice talk, but I'll believe in climate change when we get weather I don't expect. I said, wow. Can I quote you? Because that is the definition of climate change, weather we don't expect.
Time is one tool that can be used to bridge the gap between the weather and the climate. At the shortest scales of days to months, we have weather. They are the things we experience in the short term, including rain, intense storms, dry days, and heat waves. Generally, we only try to forecast weather a few weeks at a time. As for the natural variability of the climate, we look at that on the scale of months to decades.
I think we're all familiar with the natural variability of our climate, certainly from season to season. But even from year to year, because in Saskatchewan we talk about good years and bad years. We talk about wet years and dry years. There's also fluctuation in the climate at a decadal scale. So we get 1 or 2 decades in which it tends to be drier, like the 1930s. We also get decades where it tends to be consistently wet, like the decade we just had, or the 1960s were relatively wet. Not every year, but there's more wet years and dry years. So there is this decadal fluctuation in our climate, which is extremely important.
On the scale of decades to centuries, there are indications that the climate is changing, like the warming of the whole planet, sea level rise, and the frequency and intensity of extreme weather. If this change is detectable for decades, then you know the climate has changed. A climate change is a change either in the average conditions or the intensity and frequency of extreme events. Both are happening.
This is a graph of information from Environment and Climate Change Canada. It's the change in temperature back to 1948, right up to 2019. You can see that the temperature has been as much as 3 degrees above average, and it's been as low as minus 2 degrees below average, and this is just the natural variability. If you stand back and look at this entire time series of data, you can see there's an upward trend.
Across Canada, there are many impacts of climate change. The most obvious effects are in the north, from ice roads that fail, reduced sea ice cover, degrading permafrost, and shifts in the ecosystem and in the wildlife populations. The impacts tend to differ across Canada, as we have many different climates and different ecosystems.
In science, the more information you have, the more certain you can be. And when it comes to climate, there's no more information than weather data for the whole world. This is a graph of temperature of the whole world back to 1880. And it's graphed as a temperature anomaly. Anomaly just means difference. So this is the difference between the temperature each year and the temperature we expect, the long-term average. It represents, for each month of the year, the average of thousands and thousands of weather stations throughout the world. And it clearly shows in blue that for a long time, the world was relatively cool. But ever since the 1970s, every single month, with one tiny exception, has been warmer than average. So this is the best indication we have that the climate is changing. For those people who suggest that the increase in the temperature of the whole world over the last several decades is part of a natural cycle, we actually studied that question. And so what I did is I grabbed one of my chainsaws and I grabbed some helpers and headed out to the Rocky Mountains. And we went to the Castle Mountain Ski Resort. We hiked to the top of the Tamarack Chair, where you will find tamarack trees next to the ski run. These tamarack trees are growing at the limit of tree growth in the Rocky Mountains. At higher elevations, there just isn't enough heat. And so what causes the tree growth to end at a certain elevation is there isn't enough heat. And therefore, we can measure the amount of tree growth and determine how much heat was available to that tree over its lifespan from year to year to year. So we collected a bunch of wood, we took it back to our lab at the University of Regina, we carefully measured the tree growth, and we've been able to determine that tree growth has been increasing in recent years.
Looking closer at the data, you can see that Canada is not only following the trends but exceeding them. The global average temperature can be seen in green. The temperature is increased by almost a degree since the 1950s.
You can see that the world has warmed by about 0.8 degrees, but Canada has warmed more than twice as much by almost 2 degrees, and northern Canada has warmed by 2.4 degrees. The entire world, the upward trend is very clear. Even though there's less of an increase, the trend is very clear because there's hardly any natural variability.
If you look even deeper into how we are impacted by climate change, you can see that Western Canada is warming at an even higher rate than the rest of Canada.
As you might expect, global warming is most apparent, it's most visible in the coldest places and the coldest time of the year. And of course, Canada has a relatively cold climate. Some people say that global warming is great for Canada, and to some extent it is, because who's going to complain about higher temperatures when we have a cold climate? But as a result, Canada, the rate of global warming is higher, but if you go to Arctic Canada, it's very apparent that the temperature is rising at a relatively fast rate, almost 3 times the global rate. This is a map of Canada showing the annual temperature back to 1948, the amount of warming from 1948 to 2016. The dark red area, the amount of warming has been 3 times, or 3 degrees. So even though Canada, the entire country, has been warming at twice the global rate, Western Canada, especially northwestern Canada, has been warming much more quickly.
We live in the part of the world that's warming the fastest. We also live in the part of the world where climate change is most difficult to detect because we have the most natural variability of any place in the world except Siberia.
A common argument that skeptics use is that, okay, the climate's changing, but it's just natural variability. Usually I wouldn't be too sympathetic because the climate change is very well documented around the world. But I actually appreciate when people in Saskatchewan use that argument because we have more natural variability in Saskatchewan than any place on Earth. And so it's actually difficult to see climate change in Saskatchewan. If you want to see it, focus on our winter. And I think anybody, especially old-timers, will admit our winters are not nearly as cold as they used to be.
The best indication that our climate is changing is a fairly large increase in our lowest temperatures.
The minimum winter temperature at Swift Current is in blue, at Indian Head it's in brown. If we compare the first 30 years to the last 30 years, there's been an increase of about 5 degrees in the lowest temperatures at Swift Current in Indian Head. This is typical throughout the Canadian prairies, and so we say that our climate is not getting hotter, it's getting much less cold. When we say that the weather on the prairies is getting much less cold, it's almost a reason to celebrate. Who's going to complain about warmer winters? But there is a disadvantage. In fact, we say that we are losing the advantage of a cold winter. The advantage of a cold winter is it tends to keep away a lot of nasty things. There are a lot of pests, disease vectors, invasive species, parasites. There are a lot of nasty things that occur in warmer climates that we don't have to contend with. But the major advantage of a cold winter is snow. Most of our water comes from melting snow. And the great thing about snow is it builds up all winter and it's a natural storage of water. The weather data shows an increase in about 5 degrees on the prairies in the last 120 years in terms of the lowest temperatures. 5 degrees, is that a big deal? I mean, the temperature can change by 5 degrees in a couple hours in Saskatchewan. Well, that's the weather. We're talking about a change of 5 degrees in the climate. Just to put that in context, about 100,000 years ago, the climate of the Earth began to cool, and over thousands of years it eventually dropped by about 4 degrees. That meant that snow tended to stick around in Arctic Canada, and it stuck around and it built up and produced the largest glacier that's ever existed in the history of the world that we can tell. That was in response to a change in temperature of 4 degrees over thousands of years. We're talking about a change in temperature of 5 degrees in Saskatchewan over the last 120 years. The more important change is not in temperature, but it's in precipitation. Because we live in a dry climate, and we depend so much on rainfall and snowmelt in our dry climate. And so any change in precipitation is going to have consequences for Saskatchewan.
Precipitation is critical for the agricultural sector on the prairies. It's the biggest limiting factor. On the prairies, precipitation is actually going up in the wintertime because warm winter days tend to be much wetter than cold winter days.
3/4 of the Earth is ocean. Most of our weather comes from the west, and so most of our water, nearly all of it, comes from the Pacific Ocean. And as the oceans get warmer, there's more evaporation, and there's actually more humidity in the storms that come over Saskatchewan. When that humidity condenses, it produces rainfall that's more intense. And that's one of the best documented impacts of climate change, is that when we get rain, it tends to be more rain. Using weather data from across Canada and around the world, we've been able to document how our climate is changing. But we want to be able to anticipate where the climate is heading. We want to know how much more climate change we can expect throughout the rest of this century. Unfortunately, we don't have data for the future. Our only source of information is from models. Models are just a numerical simulation of the climate of the Earth. Scientists have clearly documented that the climate is changing. And there's a whole set of natural reasons, and there's a set of reasons to suggest that people have intervened in the climate system. But we can only replicate the climate change of the past 100 years if we include the human factors. So scientists have run these models where they've excluded the role of human beings. And these models are not able to replicate the measured change in temperature and precipitation from weather stations. It's only when they introduce the role of human activities. It's only when they introduce the amount of greenhouse gases that people have produced. It's only when they introduce the change in the land cover of the Earth as a result of human activities that, bingo, the models are able to simulate the measured and recorded climate change.
When it comes to precipitation, one model for Yorkton replicates the range of precipitation you would expect in the area. The model doesn't know what year it is because the model only simulates the climate process. This model captures the variability in precipitation expected, but not when it will exactly happen. It varies all the way from about 300 millimeters, which is a dry year, right up to 850, which is really wet.
The take-home message here is that there's only a slight rise in precipitation as shown by that dashed line. But the range of precipitation between the driest years and the wettest years is going up and up and up. And that's because these storms are occurring in a warming climate. And if the storms don't occur, then there's going to be an absence of precipitation, but under warmer conditions. So you can also expect the dry years to be drier.
Taking this information and pairing it with models from crop scientists at the University of Saskatchewan also shows the impact of a changing climate. These models show much higher wheat yields, more than doubled. If you look close, however, you can see huge yield variation.
The thing to notice from this diagram is wheat yields have gone up quite a bit. The average wheat yield has gone up quite a bit, but there is a great variability from year to year. That there are some years of very high yield, but there are still years in which there's hardly any crop as a result of drought. So as our climate becomes more variable, we can also expect the crop yields to be more variable. However, there's an opportunity for crop producers to take advantage of a warmer climate. There's an opportunity for much higher yields if they're able to withstand the larger year-to-year variability.
If we look at Western Canada, this graph illustrates the variance in all the models. Along the bottom is the change in precipitation, and along the vertical axis, the change in temperature.
You notice that the arrow pointing to 0, 0 represents no climate change, and none of the models plot near 0, 0. All of the models show warmer conditions, much warmer conditions in winter, and somewhat warmer in summer. And on the horizontal axis of precipitation change, nearly all the models show much wetter conditions in winter. In summertime, it's a bit different. Some of the models suggest less precipitation, and even those models that suggest or predict more precipitation, it's not a lot. Most of that precipitation will be lost by evaporation in a warming summer. So we can conclude that the trends that we've observed using weather station data will continue to occur into the future, and we can expect warmer, wetter winters. We can expect longer, a little bit warmer, but by the end of the summer, fairly dry conditions. Now this is on average. Doesn't mean that we won't get years that are quite different than this, but on average, these are the tendencies or trends that we expect. A few years ago, there were some really, really wet years. And as a result, a lot of farmland in eastern Saskatchewan was underwater. There was an article about so much of the farmland in this region was underwater. And one of the landowners said that, you know, what can you do? This has never happened before. Well, of course, we're always relating things to our own experience. So when we say something's never happened, we probably mean within my lifetime. Or my family has never experienced this. But we know for a fact that because we've documented these climate cycles, that the waters have risen and fallen on the Canadian prairies ever since the glacier disappeared 12,000 years ago. You know, we can talk about adapting to climate change. We also need to be adapted to that range of variability. And the problem is that that range of variability is getting larger because of a warmer climate.
You have to be able to plan and adapt. Adaptation is changing what you do. Regulations, practices, technologies all help in preparation for a warmer climate with more extreme weather events and variability. So in order to plan and act, you need to know what the climate is going to be. And so that's where you observe and learn about a changing climate.
We do science on climate change so that communities and cities and governments and businesses can better adapt to a changing climate. Just about every business, every industry, every municipality, they are developing a plan to deal with the climate as it changes. In the ag sector, there are a lot of producer associations, there are a lot of ag industries that are looking at how the climate is changing, how they can take advantage of a warming climate, but how they can minimize the impacts of the adverse consequences of climate change. This is a Google Earth image of an area in southern Alberta. And when I look at southern Alberta from space, what I see is adaptation. It wouldn't be possible to have commercial agriculture on the Canadian prairies without a huge amount of adaptation. We have a short growing season. It's getting longer, but it's a relatively short growing season. We have a dry climate. And yet we have this incredibly productive and successful commercial agricultural economy. And it was only possible through a large amount of adaptation. And you can see it in the landscape. You can see irrigation crop circles, canals, reservoirs, strip cropping, and these practices of soil and water management have enabled commercial, productive, successful industry in a relatively hostile climate. And given this amount of adaptation, that we conclude that the ag sector, the agricultural communities, have a lot of capacity to deal with the variability of our climate. And as it continues to change, we expect the ag communities and the ag sector to be able to take advantage of a warmer climate. The Blackfeet Nation of southern Alberta and northern Montana have a very large land base. It's the largest Indian reserve in Canada, and they have neighbors just across the border in Montana. They're concerned about the impact of climate change on their pasture, on their water. And so they produced this really nice report as to how do we change our soil management, our pasture management, how do we develop policies and practices to deal with a changing climate. And they had a nice diagram of the process by which you take scientific information about the changing climate and you incorporate that in your planning process. And it's really an adaptive process where you take our current knowledge of the changing climate, you develop solutions, you develop changes in policy and practice and infrastructure to accommodate a changing climate. But as the climate changes, you have to be prepared to change your planning as well, because we can't possibly know the future. We only have these scenarios that we think will play out. The other thing we need to do, of course, is we need to slow the rate of climate change. But the climate already has changed, and the climate will continue to change. And so in addition to attempting to slow the rate of climate change, we have to learn to live in a changed climate.